back, everybody. Hope everybody's got their coffee and is feeling refreshed and ready for session 2. I'm Monique Kubelich. I'm based at Fraunhofer HHI in Berlin, along with some of the other members of the focus group, such as our focus group chair, Thomas. Really excited to be chairing session 2, which is applications and use cases of AI in health. The purpose of this session is to look at areas of health where AI can serve as a tool, and it looks at things from use cases that are explored in a research context to AI that's already being implemented in health. So we have a nice diverse group of speakers from across Latin America and also doing different types of work with AI in health. Just to give a little idea of how these sessions are going to be held, so this one and also the subsequent ones, I'm going to be introducing each speaker one at a time. They're going to give their presentation. They're going to field any questions directly related to their presentation, and they're going to sit down. The next one's going to come, and then when all 4 have presented, then I'm going to ask them to come up and join me here on the stage, and then we're going to have a group discussion. So any sort of overarching questions that you have can then be asked. So to start off, we have Lina Porras, who's from Unapress in Colombia.
Good morning, everyone. I'm going to share with you today what we do at Unapress. And I'm going to introduce the company to a clinical case. And well, let's start. This is Maria. Maria is a Colombian woman. She is 23 years old. And she yesterday went to a party and had casual sex. She didn't use any condom, and she is not using any regular contraceptive method. So today, she is worried about being pregnant and to have acquired an STI. So this is a common problem in Latin America. In Latin America, it's difficult to access to health services, and also is expensive. It can take days or weeks to access to a medical consultation. And the main problem here for Maria is that she doesn't know that she can go to an ER or even that she needs urgent care. Later on, I will talk about why she needs urgent care. At Unapress, we provide access to affordable healthcare for everyone on their phone. Is the mission that we have. And why? What are the problems that we are trying to solve? We are trying to solve the access problem. Previously, someone talked about coverage, health universal coverage. Coverage is not the same that access. And in my country, Colombia, we have high coverage, but access is another problem. We think that with technology, we can improve access in a region that has a lot of problems. In Latin America, only 5% of the population have private insurance. So the other 95% rely on the public health system. And for many of them, for many of the population, the ER is just the primary care experience. There is no other way to access to healthcare. Also, we have problems with geographical barriers that are a barrier to access to healthcare. And also the resources are concentrated in capital cities, not in rural areas where there are a lot of people living. Another problem that we face in Latin America is the epidemiological transition. We have high rates of infectious diseases, also tropical diseases, but also we are now with higher rates of non-communicable diseases. So this put up the population in high problems, high health problems. So an example of this, the problems that we live in this region is that we have 14 million of unintended pregnancies each year. And this is important because it's the highest rate worldwide. In Latin America, we have the highest rate of unintended pregnancies. And why this happened? We have a lot of misinformation. There is still a taboo to talk about contraceptives, to talk about sex. The people cannot access, women cannot access to contraceptives in the region, and it's also a problem. And this is a main issue for youngs and adolescents. So again, let's go back to Maria. Why is important that she go to a doctor in less than 72 hours? The reason why is because she needs emergency contraception, and it is important. She only have 72 hours. If she take the emergency pill later, it won't be successful. Also, she has 72 hours to receive STI prophylaxis, including HIV prophylaxis. Remember that she had sex without condoms, and it was casual sex. And this is the typical consultations that we have at Unapress. Imagine that she can access a doctor immediately, from anywhere, at any time, that can change her life. And that's the reason why we exist. We provide quality medical information. The patients can talk to a doctor, can ask anything, or can chat in real time to our platform. How Unapress works? People came to our platform through web or app. They choose what's best for them, and they go through a symptom assessment. We provide some questions to complete the information that otherwise maybe the patient won't tell us. And after, they can add more information. And we will deliver pre-triage also as a pre-diagnosis. We have built the largest knowledge base in Spanish that we use not just for optimize the experience for Maria, but also for optimizing the experience for doctors. And we think that it's important not just to give access to the population, but also optimize doctors' time. So after Maria complete all the process of give us information, the doctor will receive complete information in order to give the right advice, and it's less time consuming. So we are trying to optimize from the user side and also from the doctor's side. So Maria can now know in minutes what she has to do and what to expect about STI prophylaxis and also about emergency contraception, which is important and can be life-changing. So Unapress has been running for more than 4 years. We have more than 1 million users per month, and we are mainly in Colombia, as you can see, in Mexico, Argentina, but also we have some presence in the United States, where the Hispanics use our service a lot because they feel like at home, and because we also speak in Spanish. Our doctors speak in Spanish, and our platform is built in Spanish. How is our business model? We share per consultation, and we have like two sides. The B2C users, they can pay online or through the web or to the app, and the B2B users. The B2B users came from health insurance companies. We provide our service to their customers, or also we are partnered with some employers that give Unapress as a benefit to its employees. We have some clients, as you can see here. Mafre is our client in Mexico, has been our client for more than a year. We have some insurance companies in Colombia, like Compensar, Salud Total, some other companies like Flubit that give Unapress as a benefit to its employees. And we believe in partnerships. We have been cooperating with the United Nations Population Fund for more than 6 months, I guess. And we are working with them in trying to decrease the amount of unintended pregnancies across the region. We have a really experienced team from technical skills, business skills, and also medical expertise. We have a network of more than 400 doctors that not also are in contact with patients, but also contribute to our knowledge base. And our vision is to become the healthcare gateway and giving advice, telemedicine, and all the way to insurance. And well, it's a pleasure to be here. I hope to cooperate with you to learn from all of the experience of all you. And if you have any questions, this is the moment. Thank you.
Okay, can we ask questions now, specific ones? So when a health insurance is paying, how is that done? How's the premium and the customer, all of those questions?
Okay, what we do is be the gateway. So what we have found so far is that 11% of the population that use our service inside of the insurance company don't have to go to personal care. So they can save money, basically.
I mean, from a risk perspective for insurance, now that person contacts, Maria would contact you on the basis of what she has experienced, then she becomes a higher risk. Isn't that an issue? Should the health insurance maybe not know about that?
The insurance will know the information that we provide, and we can contact her with the insurance company in order. In Colombia, it's the specific case of Maria. So we can knowledge that she needs emergency contraception. We have to send her to the person.
How do you protect Maria's privacy from the health insurance company?
Okay. The service is provided for her through the insurance company. So she won't see that Unapress is providing the service. It's just the health insurance company that are providing the service for her, and we send the data to the clinical record, but we don't see the whole record of her.
I just have a question about the demographics of the people who use it. You mentioned the different countries that have users, and you give an example of Maria. I assume that it's not just based for women. So is there like an age distribution or gender? Like what are the most typical clients like?
Well, our typical clients are millennials, just for summarizing. So that's the reason why I put an example about contraception and sexual issues, because there's a main problem of that population. We know that there are more consultations from women than from men, but it's not a huge difference.
Hi. I have a question about how do you handle the payment when you're working through the insurance company?
Okay, when the insurance company, they pay a fee, a monthly fee per users, and we have fees according to the traffic, the people that come to use our service.
Per capita base?
Not necessarily. We have packages.
Yeah, thanks.
Lena, nice presentation. I want to know if when a person contacts B2C, can he or she become anonymous and without?
Yeah, that's a good question. Yes, when they came to us as a B2C user, as a normal user, normal people, they are anonymous for us, especially for the, well, we use a pasarela, payment pasarela, when they have to put the data of payment. We don't have or we don't own that data. And they just gave us gender and age, because we think, we are sure about that, is important for medical decisions. You know, there are some things that occur just for women and another just for men. But we don't know the name, we don't know the specific location, we don't know the ID number. It's anonymous. Well, mostly.
Thanks for the presentation. It's very nice. Do the consultations always end with the doctor, or sometimes the AI can resolve the consultation before reaching the doctor?
That's a good question. Not all ends in a doctor. In fact, there is just the 1% that ends in a conversation with a doctor. The other 99% can solve the question with 3 elements. First, the knowledge base that they can access in platform. It's important to remark that there are a lot of people looking for information, just for information. Maybe I went to the doctor yesterday and they gave me losartan and I don't know the side effects of that. And they go to our platform and that information is available just for read it. You can solve it. And other type of patient is the patient that don't know what to do. Is this an emergency or not? Or I can do it, I can go to ER or to private consultation in 5 days. What do I have to do? And we can solve that automatically because we have a pre-triaging tool that allows us to do that. In that point of the pre-triaging, it's important to remark that most of the population that go to our website, they are not looking for emergency attention. It's like less than 5% of the population, of our population, are looking for emergency services. Most of them are looking for non-emergency services.
Thanks a lot for the talk. I would like to know how many people use your app already in Colombia and in other countries.
We have 1 million users, 1 million users per month that are distributed, as I said before. In the slide. Oh, okay. We have mainly 30%, more or less, in Colombia. Here. This is the distribution of our population. Because we born in Colombia, is like our main region, main country, and we also have office in Mexico, so it's the second region, but we also have presence in other countries, and also, yeah, you can see here, also in Spain. So it's really interesting because we are focused in Latin America, but there are some people that live there that chat with our doctors or use our services. And there are some interesting cases because we have users from Japan, but are Hispanics that are there and need someone to speak their language to understand what they are going on, what they're going on.
Thank you.
You're welcome.
Yes, you mentioned that you have about 450 physicians and about 1% actually speak with physicians. So what do you use the physicians mainly for creating the data, creating the content, and what specialties do you actually work? All kinds of specialties.
Okay, we use for both for answer questions for patients and also to improve our knowledge base. The doctors are not attached to a schedule. They are like more in a freestyle, can I say? So they are not, the 400, they are not at the same time available. We have people at night, people in the morning, so it's not at the same time. And we have mainly general practitioners, but we also have some cardiologists, some internal medicine physicians, and we also have residents. I don't know if this is the right word in English. The doctors that are doing a specialization. Because in Colombia, we have a special problem. The doctors that are doing the specialization, they don't receive payment. So they found in Unapress una fuente, a source of payment of money. What's another question?
Yes. One more question.
Yeah, I have one. So I suppose you use something like natural language processing for the artificial intelligence, and you have to train that. I suppose my question is, in which medical specialty your model is trained, is more accurate?
In general practice, in general medicine, I don't know if it's the right word. In general medicine, but our system can identify the specialization of the question. I mean, if you make a question about cardiology, our system will know that, yes? But so far, we are able to provide you with a general physician and sometimes with a cardiologist, but sometimes we don't assure that you will have a specialized doctor.
Can I? Do you mind saving that question for the panel? Because we're going to open up the floor then. Is that okay? Thank you very much. Thank you so much for your presentation. I think that's always a good sign when there's so many questions that we have to start turning them away, because it shows that the audience was really engaged and interested in what you're doing. So I'm happy to field those questions at the end during the panel. Our next presentation is from Mauricio Fares Finefine in Argentina.
Good morning, everybody. I would like to thank Monique and the organizers for the invitation. I'm going to be presenting about Dentelai, which is a company we founded a few years ago. But first, I would like to talk, as Lina correctly pointed out in her presentation very nicely, there's a lot of challenges in the healthcare system. We like to organize it in the three more pressing issues for us. One is that the healthcare is expensive. If you want to see a doctor, you have to pay a lot of money. And that's for a lot of reasons, but we are dealing with more complex diseases, more complex treatment, and more complex diagnostics procedures, and that comes with a cost. So that's something that is getting worse and worse. Then if you want to see a doctor, you have to wait a lot of time. And that's a global issue, not only in Argentina or in Latin America, in the US. If you want to see a specialist, you have to wait up to 1 month. And we're talking about Boston or major cities. And then the other problem is that we are trained several years to detect diseases and cure patients, yet we are the third cause of death in the United States after cardiovascular disease and cancer. So medical error is definitely an issue that we are having. There's a difference among studies. Some of them tell them that it's as low as 5%, but some cross-sectional studies shows that the diagnostic error or the diagnostic delay can be up to 30% of the disease. So we have three clear challenges that we need to solve. And for those challenges, we deeply believe that artificial intelligence is definitely a tool that can help us as a doctors become better and faster, and as a service we provide, be more accessible and more affordable. At least take the precision to the standards of other industries, and that's something definitely we think artificial intelligence can help. So in 2014, I'm a neurologist and trained in public health. We came together with Dr. Fernandez Eslezak. He's the director of the Applied Artificial Intelligence Laboratory in the University of Buenos Aires. And we decided that we wanted to do something applied and artificial intelligence to solve these challenges. And eventually, after some years of research, we figured out that if we wanted to have an impact, we have to do it as a company, as a service, and we founded Dentelai. In 2018, we started working in Argentina with our first partners, and eventually in 2019, we started operating mainly in Chile, and we are starting here in Brazil and as well as Mexico and Colombia with distributors. The international expansion, and that's something that's very interesting. So we needed a regulatory approval. So we started with Argentina. When we went there in 2017, they had no idea of what to regulate. They asked us to have a deposit for drugs. We didn't know what to do with that. We needed a biochemist in the team, which we didn't find any use of. So it definitely took a lot of work to work on the regulation. But eventually, after 1.5 years of fighting, we get it right. So what is it that what we do? So Entelai Peak is our main service. Basically, what we do is we connect to hospitals to their PAC servers, and then we took images, and those images we anonymize them, and then we bring it to the cloud where we apply our deep learning algorithm. And then we return the same image, we connect them again with the information from the patients, and we have it ready for the doctor to use. So that typically takes between 30 seconds to 5 minutes, depending on the image and on the connection on the center. But the idea was that we don't want the doctor to be consulting an AI services or waiting for the AI service to process the image. We wanted to have it right next to the original image. So the doctor doesn't have to change their workflow. So if a radiologist has to see an image, then wait for the system to have the second opinion, he has to analyze 60 other images in a very short time frame, and that leads an underutilization of the system and that losing that magic that AI can help to give to the doctor. And this is one of a few examples of what we do. So we are working mainly with brain. So we measure brain volumes and we analyze them if they're outside a normal reference range that we build over the years. Then we also work with mammographies and we tell them if they have a Barrett's 4 or higher, that means that they have something that is really suspicious and the doctor should consider biopsy or ultrasound or some other study. And then we also work with chest x-rays where we also triage the image and say this is abnormal and then normal, or you should pay attention to this area or not. Why we chose these areas? This one, because I'm a neurologist and I found it quite amusing and also quite useful. And then mammography is one of the areas that in many countries, especially in Argentina, for the public sector, there's a lot of inefficiencies in the system. So if a patient even has an image that it's abnormal, it might take months to a doctor to see that image and then say, okay, we have to do a biopsy or a follow-up study. And definitely that contributes to the cancer being detected at a late stage, and definitely that's linked to higher mortality. So definitely we are working with this model to make the doctors see the study earlier and have them at the top of their priority to work on that. And for chest x-rays, I don't know if you're familiar, if you go to an emergency room, you might get a very well-trained physician, an internal medicine probably, but who's not a radiologist by training. So the sensitivity for that doctor to say that your chest x-ray is abnormal, it's around 65%. If you go to an engineer and you say, hey, I have a system that detects something with a 65% accuracy, probably that engineer would not like your proposal and think you're crazy. Yet in medicine, we accept those numbers, and definitely that's something we are not comfortable with. So we think those doctors who are not really trained to see images should need a backup. That usually comes from a radiologist, but the radiologist is busy seeing more complex images. It doesn't have time for the ER. So that's one of the areas that we are working hard with our clients and partners. This is just an example of the companies and hospitals that we're working in Argentina and Chile, and we just started, as I say, with RHBio, which is an incubator from the Albert Einstein Hospital. So we're very happy to be growing, and we are really committed to grow within Latin America. So as a summary, we definitely need, and we try to make Entelai as a very accessible service, a local service, so any health center in the area can use the support of artificial intelligence. We definitely aim at reducing analysis and diagnosis time, yet while increasing the analysis precision of doctors. And of course, as I said, cost is a very pressing issue, or lack of specialists, and we also want to help in that sense. So thank you very much for your time. Questions, or you want to say later?
Yeah, that was a nice presentation. I wanted to ask, can you share a bit more information about your AI system? So first of all, the data used in training the system, and then what kind of architecture you used?
Well, so we train our system with a blend or a mix of public repository that are double checked by our radiologists and also images that we acquire over the years through partnerships with hospitals, mainly in Argentina and in Latin America. And then about the models, it's a complex technical question. We can discuss it further. Basically, we use ResNet or BGG, whatever architecture works best, and then we also use ensemble of those models. But that's something also a little bit of the company private information that I might not be able to disclose. But overall, I think in our experience is that you might come out with a very nice architecture, a very nice model, but at the end, what doctors need is a service. So it doesn't matter if it's a fancy software that if you go upload your image, it works. What we need is that someone that help us do the work. So we have a lot of work. We have a lot of images to analyze every day, and that having that service right next to in your computer with your system, we think that that's more valuable, given that you provide with a good accuracy and in the tech.
Thank you for the presentation. Could you share us what are the problems when you implement this? Not about the technicals one. I'm talking about human resource assistance, like change management, about on the history about Intellect.
So we didn't find any resistance from physicians. I think we are very eager to adopt new technologies, and part of our competitive nature is we always want to be better and provide a better service. So we didn't find like a large percentage of people saying like this is gonna take our jobs, we don't want it, or something like that, which we expected a higher rate. So I would say like less than 10% of doctors have a negative attitude towards AI. I think most of them, once they try it and they figure out that they can be of help, and they can even, in some systems such as telemedicine, they can even use it to make more money. I think that's something that the doctors once they realize that, they have a very good perception. I think in terms of adoption, what we found is like we didn't know that this was available in Latin America. That's one of the main comments we get. Like no one believes that it's already available as a service. And the second one is mainly IT problems. So doctors, they see a demo, they like it, they want to use it, but then you have this IT wall where they say, okay, well, we have to figure out how to protect the information of the patients, so all the regulatory aspect, which I mean, it's a very key aspect of this. So we work in the cloud, so no one wants to have their patients' info in the cloud and have security liability there. So I think that's, in terms of adoption, IT and regulation, it's something that it's the hardest part. It's not impossible, and we've been dealing with that, but I would say that's a tough part.
Yeah, so a follow-up question. So you said you use public data set. I'm guessing like for the chest, you use the NIH data, right? The one with about 200,000 images.
The ChestPark, you mean the ChestPark 14?
Yes.
That's, we use some of that repository. There's some issues with the labeling on that data set, so we explore it, and so we might use it as like a rough training, but we don't use it as a definitely data set. We didn't find that accuracy acceptable for service.
So my real question is this: the data you got was mainly from somewhere like in the US, right? How much data from Latin America did you have to add to that international data? How well did it translate demographically? Did you have to run tests? Was there variation across the different countries in Latin America when you tested your AI system?
We tested that. The main difference we found, to our surprise, is gender. So that's a really deep impact in gender, in the precision of the system. So that's something we take into account, or you should take into account your models, because we found, obviously not for mammogram, but for chest x-rays, gender has a deep impact. We did not find changes on that. We tried to respect our demography, which is different from the US. So there's not a lot of Asians or not a lot of African Americans. But the test we do for brain and chest X-ray, we didn't find a significant impact in the precision of this.
And that's still translated to the breast cancer. Still, demographics didn't play much difference with the breast cancer.
For breast cancer, we did not do. So I was talking only about chest X-ray. We did not test that for breast cancer yet.
Sorry.
We didn't check for, let's say, African America or people outside the Latin American area.
But then for the breast cancer system, the data is mainly from Latin America, or is also a mixture of Latin America and then international?
It's also a mixture.
And then but then you didn't test it to see if there was any demographical sort of evaluation, if it translates well, because I know demographics actually affect cancer a lot.
We did not, because at the end, the last part of the model that we use, it's with our own data. Okay. So eventually we didn't have that chance. So we use mainly public for perhaps like a rough training, and then eventually the fine tuning or the implementation of the model, it's with our own data where we don't have that to test. But it's a really good point.
Have you measured in any way the impact of your tool in patients' outcome or in doctors' time to evaluate the patient?
Yes, that's a good question. So we are doing 3 works right now. Once that it's already done, so we measure the rate of doctors, including the word atrophy or any brain volume measurement after implementing our system. And so we have a 40% increase in the number of doctors putting on the reports that word or being sure to report that. And then for chest X-rays and mammography, so we are working mainly on the time and sensitivity, but we haven't finished that yet. So we hopefully will have those results by the end of this semester. Thank you.
Thank you so much. Thank you for your presentation. Thank you for the great questions. Our next presenter is Jose Luis Nuno Ayala from Unima, Mexico.
Oh, hello, everyone. Good morning. I would like to thank you for the invitation. And today I'm going to share with you what we are doing in Unima for point-of-care diagnostics. So we are a biotech company, and we developed a fast and local diagnostic and disease surveillance technology. Our goal is to solve the problem of lack of access to a timely diagnostic for almost half of the world's population. So the main problem that we are focusing right now is that current diagnostic technologies are very accurate. They can detect almost any disease known. But the problem is that they require specialized labs and technicians, which are very scarce in these emerging and developing countries. So to solve this problem, we developed Find. Find is this fast and local diagnostic and disease surveillance tool that I mentioned, which was developed to allow anyone, even people with very limited clinical training, to diagnose a disease directly at the point of care without using lab equipment, with results in 15 minutes and with costs that can go as low as $1 per test. Our goal here is to take diagnostics outside of the lab and directly where the patient is, even in very remote areas of the world. So using this technology is actually quite simple. What you have to do is take a sample from the patient, for example, a drop of blood from a finger prick. Then you put it in a paper microfluidic device, like the one you see on your screen right now. And then you wait for 15 minutes for a reaction to occur. You take a picture of the paper device with an app in your smartphone, and you will have the result in your screen in around 5 seconds. Then this information also is sent to a cloud server where we can use it for real-time disease surveillance or to create real-time analytics that are very important for governments, healthcare organizations, and even some pharmaceutical companies to create better strategies or better products to stop disease outbreaks and in some cases to prevent pandemics. So one of the most important advantages of this technology, aside of course of cost and time, is the possibility of building very easy to use tests that can be used on very remote areas of the world. So here, for example, a community health worker can pack in its backpack the paper test, smartphone, and go and do diagnostics in remote areas of Africa. It doesn't require any electricity, and even the application works completely offline, so it's not connected to Wi-Fi or cell phone signal to do diagnostics. So you can keep doing your analysis, your diagnostics. Maybe at that point you are not going to be uploading on real time, but all this information is stored in the smartphone. When you get out of that area with that connectivity, all this information will be uploaded in real time. This is important because we build this application to be able to do the diagnostic without this connection, so you can do it even in very remote areas. So the technology is based in using chimeric recombinant antibodies from sharks, which can be modified using genetic engineering to catch disease biomarkers in the blood, urine, or saliva samples. So we adapt these shark antibodies to catch those biomarkers and to generate a visual reaction when they get in contact with the patient sample on the paper device. So these visual reactions could be something very simple like red blood cell agglutination or changes of color or even fluorescence. And we use this signal to evaluate the result of the test in the smartphone app by using image analysis processes and artificial intelligence algorithms to generate a very accurate result. So what just very briefly, what we are doing here is actually using visual processes to measure immune reactions which are triggered by these biomarkers, which can be antigens or can be viruses, bacteria, parasites, toxins, and even some non-communicable disease biomarkers. So one of the core decisions that we had to make during the development of this technology is to use artificial vision and artificial intelligence to increase the sensitivity and accuracy of this test. So what we do is each time that we are developing a new test for a new disease, we train these algorithms using images of samples from hundreds of patients to actually train our algorithms to be able to detect the disease in this cat. So for example, we do a first training just before releasing the test for the clinical trials. Then we train again the application and the smartphone app and the algorithms after the clinical trials, then with results from pilots from different parts of the world to actually get results from different kind of immune reactions from different regions of the world. And then after releasing this application for commercial use, the goal is to be statistically training these tests in the future by using results that are being generated in real time. So what the technology actually does is, instead of depending on relying on the capability of the healthcare professional to read the card, we're using this imaging processing and AI algorithms. So what the algorithm actually gets is, at the beginning, we get the raw photograph from the camera on the smartphone. Then the algorithm corrects certain problems with the image, for example, brightness, angle, etc. Then after this correction, it starts applying several filters that the application learned by machine learning that were important traits to actually detect which cases were positive for this disease. Once we get these filters, so the algorithm actually gives like a metric for each one of these traits, and then these metrics go through a convolutional neural network algorithm, and this algorithm takes a decision, for example, if this is a positive case for tuberculosis, or it will give us, for example, the percentage of glycated hemoglobin on a blood test of a patient. So using this technology, we built a business model, which we call Diagnostic Platform as a Service. What we do here is that we work with big users like governments and healthcare NGOs or pharmaceutical companies, building tests that solve a specific challenge that these organizations have in diagnostics. So for example, if Doctors Without Borders need a test for cholera for Latin America, we can build that specific test under their own needs over our platform. We do the design, the validation with their own patients, we manufacture the test, and then we sell it directly with these organizations. So most of the revenue comes from sales of this testing device to these big users. We are targeting different markets in global health, of course, which was the reason why this startup was born. and public health, governments and national health systems, private health for pharmaceutical companies, insurance companies, and some applications also in animal health. Right now, in traction, we are close to launch our first test, which is for the triage of tuberculosis in the national algorithms for public health. Right now, we have signed contracts in 4 countries, and we are running pilots in 7 countries. It's Cameroon, Zambia, Zimbabwe, South Africa, Indonesia, Paraguay, and Mexico at the same time. We are developing new tests for dengue, Zika, diabetes, and animal health diseases. And this is the founder team. We are a second-time founder team. Our first startup was also in health, but in animal health. So we have previous experience running how to take one of these biotech developments from the lab to the market. And we have been supported by great organizations like Y Combinator, Google, Mass Challenge in Boston, and Endeavor. And partnerships are very important for us. Right now, we are working with different organizations around the world, like Stop TB Partnership in Geneva, Find in Geneva, PATH in the US, the America's TB Coalition, the Fraunhofer Institute. So we are always looking for new partners interested in using this technology. And of course, our goal at the end is to secure a timely diagnostic for everyone, regardless where you live or your ability to pay. Thank you.
So, thank you very much. It was a very interesting presentation. I presume that some other people have already asked you that, but with these rapid tests, do you evaluate the sensitivity and specificity of tests? There's cross reaction with other types of viruses. For example, dengue, the rapid tests that are currently used have a lot of cross reaction with the flaviviruses. Do you validate those tests with gold standards? There's gold standard for most of these diseases. There's another issue that sometimes certain type of markers are found in blood or in urine certain periods of time after onset of disease. So do you care for those timings, or do you include those variables?
Yes, in your first question about validation, yes, we always do clinical trials comparing with the most important golden standard. For example, the tuberculosis test that we built were always compared, for example, with GeneXpert, so PCR, real-time PCR. So all the results that we use for training, they're always compared with the golden standard. It's important to actually get the real sensitivity of the test using the algorithm that we are going to put on the market. So, for example, it's not the same thing using triage for tuberculosis that a final confirmation test for TB. So all the clinical development that we do is always considering where it's going to be used and the golden standard that you use for that specific kind of application. And regarding your second question, actually, yes, the design of the test depends a lot on what is the use that the partner is going to use that test for. So for example, in the case of the dengue test, this is going to be a screening test for dengue. So it's going to be used with patients that are already with clinical signs. So that's specifically, and it's more for epidemiology. So the partner actually needs this. So we build it that way. But at the same time, for example, we can do it, for example, a differential test for dengue and Zika, which is different approach. So that's a project that we are running with the Fraunhofer Institute, which is not easy to do it because you actually need to do certain things just before going into the rapid test. So the design can change a little bit the approach on the clinical design of the test. That depends on the need of the final user. So if you want, for example, a test for TB on children, it's not the same thing as an adult test for TB. So in that case, for example, with working with urine to try to find those biomarkers in urine and trying to adapt to the same platform and not the same thing, for example, the blood in adults. So it is not one size fits all. So we adapt the platform to whatever you need to do using the same platform of shark antibodies, paper fluidics, and vision analysis. Yeah.
Thank you very much for your talk. My name is Aus Abd. I'm from the Robert Koch Institute, and I've been wondering whether you are testing your convolutional neural networks that, for example, look into the filter or kernels and check whether the weights are detecting meaningful patterns in the paper. Are you doing this?
Yes, actually the first step when we are developing a new test is to evaluate if the network as it is right now is actually capable of find these meaningful traits. So that's why it's important for us when we are choosing clinical cases of these initial patients, initial volunteers, we're always trying to do it as broad as possible. So for example, in tuberculosis, we were looking for patients who had active cases of tuberculosis, latent cases of tuberculosis, non-pulmonary tuberculosis, etc. So using this mix of cases, then we see the algorithms capable at least of being as good as a clinical test. Because if, for example, your lab test is not as, our bottom care test is not as good as lab test, maybe it's not that a good idea to have it in the market. So we do changes in the design of the algorithm if, for example, we need to change weights or the design of the network, etc. But we do it at the beginning. Then once we know it's going to work that way because we got into a threshold, for example, of sensitivity at least of 90% of something, then we start working optimization of the network with machine learning.
But you are not using explainable AI to see on what your neural network is focusing on the image?
No, not right now.
Thank you.
Hi, my name is Luis. Related question. I didn't quite understand yet. What exactly do you use as input for this CNN? So this pre-processed last image or stack of all? I mean, you had a couple on your slide. So
yep.
What exactly is the input that you use?
So if go back, sorry about this. Go back to show the image, but if we are talking about the on-site use of the test, just back. Okay, so the input will be this raw image. This is the photograph from the camera, and then the algorithm starts working on the reaction area. So it isolates the image, then it applies some corrections, and then it goes through the filter. So it starts working always with the raw image.
Okay, so this is then not some explicit pre-processing that you apply, but it's all done by the CNN. Did I understand correctly, or?
No, it's the correction is being done by image analysis. It's not the neural network. So we always correct before going into the analysis of the neural network.
And what enters then the neural network? Which of these? All of them?
It will be after this. For example, this is the processing using different filters. So our algorithm assigns a value depending of the machine learning process to find how much important was this against, for example, gloves, after, for example, areas of after binarizing, etc. So it's a different kind of value for each test. And this after assigning value, then it goes through the neural network.
All four of these?
Well, actually, it's more than four, but it's much information to actually put on
okay.
that. Yes, many more than that.
Does the camera quality of the phone affect the results? Like if we took the same sample and then was taken by multiple phones, as well as even lighting conditions, if it's a bit darker in here, do all this factor or affect the results?
Okay, these algorithms were built to use a very old 1 megapixel camera, something that is not in the market already. So it was developed that way to be sure that it's not going to affect in the future the results. But it's not about the quality of how the camera was built, but the quality how the camera is at that point, and it's important. So what we do is before you can use a smartphone to do the process, each one of the boxes of those tests have like 4 cards. So you cannot use the app after it's being evaluated using these like base cards. So you have to take photographs of those 4 cards. The information is sent to our server, and we like allow or not your smartphone to be used on those tests. So if your camera, for example, has some cracks on the for example, the surface of the crystal, it will not give you a very good photograph, and we will not allow that smartphone. So the app gets blocked. And if you actually go through the process and it's allowed by your software, then you will be able to use that application. So it's a way of scaling up the possibility of allowing each one of the smartphones around the world to use or not use the application.
And that decision of validating a phone's camera is also done by another AI system, or it's, there's a man in the loop.
Okay, right now, because of the site we are doing, it's a decision that our team at engineering takes. So it takes like the metrics that are sent and we take the decision, but the idea is to do it via AI. Yeah, it's a very similar process. It's like doing this process again, but what you get from those cards. So if you, for example, each one of those cards has been already evaluated. So if you get the same results from those cards using your camera, then it will be approved. If you don't get the same results from those cards using your camera, then it will not be allowed.
Last question. If my phone is validated and I pass it, that means I can use my camera. What if in one instance, if I'm using my phone, then I quickly blur it? So it's not about the camera quality anymore. It's just that instance while taking it. Maybe I had a little shake. So there's a blur in the image.
So a previous step before this is the algorithm is capable of correcting up to some point the quality of the photograph. But after it does that, it can be done by the smartphone app, it's going to go through the complete process. And we have some metrics that your photographs need to have in order to be used. So for example, if brightness is too high and the smartphone app wasn't able to actually correct that, the metric that you will get from the photograph will be very, very easy to check on the algorithm, and the algorithm will take the decision of give you on the screen, for example, an error message, and it will not give you any kind of result. So you need the app gives you a message of do it again and again. And I think at the fourth time, if you don't get that photograph fine, you will not be able to do the test again. So you have to do another test.
I think we have time for one last question.
Yep. Thank you so much for the nice presentation. I'm called Rose. My curiosity goes back to the input image. When I would want to understand, a question came from there about the input image. One, is this kind of input a supervised kind of image? Do we have some annotation that is done before the image is input to the algorithm? And also the features that we look for in the image. Do we look for the shape, the color? What specifically are we looking for? Is it like just a biomarker that the algorithm is looking out for? I would really want to understand the kind of input.
Okay. In terms of what's measuring, I cannot go in many detail because it's confidential information. But for example, it should be like 10 or 12 different metrics that the algorithm actually measures before going into the neural network. So it has to do with areas and colors and blobs and filters, etc. So it's many things that the algorithm measures on the raw photograph after it's been corrected. However, the first question that you have, I didn't understand quite well about.
Is this supervised learning, unsupervised?
No, the first step always just before releasing the app to be used to the public is always supervised. It's supervised. The idea is to be unsupervised after we release to use as statistical analysis on all the photographs that we are going to get from the use at the field. So it has to do, for example, to detect certain errors or certain things that could happen on the field that we did not, for example, find during the pre-training, clinical trials, and piloting the application.
So usually there is a person who annotates this data set before it goes into the analysis.
At the beginning.
Pipeline.
At the beginning, yeah. Okay, thank you.
Very much. So for our final presentation of the session, last but not least, we have Saul Calderon Ramirez from the Instituto Tecnológico de Costa Rica and de Montfort University.
Well, thank you very much. And well, My presentation is a little bit more academic since I'm in academia right now. I'm a professor in Costa Rica, and well, right now I'm doing my PhD in the UK. So this is a short, you could say, summary of the presentation. And well, I come from Costa Rica. It's a very small country. I don't know if you've been there. And well, one of the key aspects that I always like to highlight or remark is that we have a very good, you could say, public health system that has a very good coverage. And actually that allowed us to have a very high life expectancy. Actually, it's even higher than in the US, even though we have a much lower income. And well, this is a really good strength because, well, this been, you could say that they have been our main partner, in the work that I've done in Costa Rica so far. They have first level of attention clinics, you could say, that we call EVICE, that have a fairly good coverage, and also second and third level that, well, the third level hospitals are much more, you could say, centralized within the Central Valley, which is the central zone of our country. And well, we've been working in different projects so far. I just want to highlight some of them. And most of them use deep learning technology, which is really been revolutionizing the field of AI since like 6 or 7 years so far. And basically, well, the idea is to learn also the features from the data instead of just manually handcraft them. And this means that, of course, we need to have lots of data, lots of samples. And this is often, you could say, a hard challenge to overcome because it feels like in medical imaging, that's what I've been working so far. Well, it's hard to get, well, samples, enough samples to train our model and to, well, have a good performance while we're doing our validation tests, okay? So I like to highlight this phrase from Joshua Bengio, who works in Canada and is one of the top researchers in deep learning. And well, it's pretty much how deep learning is inspired by the neural networks of the brain to be learning machines which discover or learn rich and useful internal representations. Okay. So some of the works that we've been doing, well, this is a research project that was funded by the Costa Rican government. And well, in this project, we aim to build a segmentation and tracking, you could say, platform for microscopy images using fluorescence-based technology. And well, we trained this model with first data set that was publicly available, and then we built our own. And we use encoder architecture unit that is a very popular well architecture for image segmentation. And we also did some adjustments to the architecture to include some prior information into the architecture, and we yielded some good results. Well, of course, this is from the academic background, right? But we also we built a platform that our researchers, not working. Okay. Okay. So we have available the platform, and researchers from a small cancer research lab at the microbiology department at the University of Costa Rica are using this platform online freely for them to use to segment and track the cells, because the idea is to assess automatically what's the concentration of different proteins within each structure and assess what's the behavior of a given tissue after using a specific, you could say, chemotherapy in a different patient. So the idea behind this is what they call specialized or customized medicine in order to build up the specific chemotherapy treatment for each patient and get to have the best treatment for the patient. And well, another project that we've been working on is the analysis of histopathological images, basically breast images. And in this academic work, we focus on you could say, the performance of an architecture, because we aim to have the system to be run in the clinics and hospitals that are not in the Central Valley where connectivity is poorer. So we came up with SqueezeNet, that is a very popular and efficient architecture that we can use for evaluating very quickly the output of the system with newly not images that were not used for training, right? And there's also an academic paper for one of these. But the problem is that we always face the problem of not enough labeled images, and that's why we've been developing this tool with a private company, a private Costa Rican company that is named Cooley Health. Below is over there, and I don't know if you can click like the video because it's like a video that is there. Yeah, you can get to see that we use what is called active learning, for instance, for labeling images aimed for segmentation, like pixel-wise labeling. Well, it's a very, you could say, time-consuming process, and we use the idea of using unsupervised learning to initialize the areas, and then the labeler has only to correct these areas. And this is also a public platform that we aim to use in a public health system, and then we can also, as a, you could say, business model, sell the service to other private hospitals, private companies that want to use this tool. And well, I think that you already got pretty much the idea there. And well, I think that this you could just say like a short summary of some of the work that we have been working on right now. And we are pretty much, some of these tools are about to get tested in our public health system. And there are some challenges that we found so far. And the first one is that still our physicians, at least in Costa Rica, they are not used about the idea of using AI into their medical processes so far. And they still have to be, of course, interact more with the field, or also our computer scientists, as I'm a professor, they still don't have the background for facing the development of these systems that is quite different from the standard software systems that we've been developing so far. And we have, you could say, this preoccupation of trying to build up the skills, the necessary skills in both fields, and try to have more interaction between them. And well, one of them is, for instance, the evaluation of these systems that we, well, one key insight that we sometimes discuss with our colleagues and from different universities also, is that there is not a very good, you could say, pipeline for assessing the performance of an algorithm of a deep learning architecture and compare it with another, because frequently the evaluation does only the comparison of the means of a local test, and is not really statistically significant. And also, one of the issues is the labeling standard, of course, that there are lots of issues there. There are not really the labeling standards, so that way that we can, for instance, share the data sets that we are building in our public hospitals. Mainly we work with hospitals that are within the Central Valley, from Cartago, San Jose, and also the University of Costa Rica, that they have careers related to health, and that's what's, let's say, our partner so far. And well, I think that also there are lots of opportunities, because if we start building up the skills in our engineers, in our health professionals, we can get to, you could say, develop new ideas, like fuse different kinds of data, right? Like not only using images, because, well, we've been using medical images so far, but we can also combine different types of information, like sociological information, genic information, other sources that we can use. And well, the key in here, I think, is to gain insight about what our algorithms are really learning from data. And I think that for that, we should start discussing the arise of new disciplines, like, for instance, computational pathology, computational radiology. I think that there have been some authors that already are pointing out about the necessity of trying to build up these transdisciplinary disciplines. And from academia, that's a main concern for us, right? So in the industry, we can have professionals that are more prepared for facing the challenges that we have to face, right? And well, some of the efforts that we have done so far in our research group, well, I didn't tell you that the research group is pretty much pattern recognition and machine learning group. That is, it gathers researchers from Costa Rica and say pretty much from the public universities in Costa Rica that aim to use machine learning for mainly medical purposes and also biodiversity conservation, since those are the strengths that we have spotted so far that Costa Rica can really contribute to. And we built this, well, we are building this Cantico initiative where we've been sending some of our students to Canada, to the University of Toronto. That's one of the main, you could say, contributors so far in the area of machine learning and deep learning. And so they can be trained and do some internships in companies and also in the University of Toronto. And then they come back with some knowledge that they can incorporate to their work in different private companies or also in academia. And also we've been organizing symposiums, summer schools on how to and try to disseminate the experiences so far on using AI in, well, in this case, medical imaging. And that's also one of the aims. And I'm open also always for doing alliances and work together mostly, well, in Latin America, I think that we have lots of potential there. And well, of course, as I'm doing my PhD, I have also some academic concerns because, well, so far you've seen that deep learning needs lots of samples to train the system and to yield a decent validation accuracy, right? So some of the issues that are open is how to train a deep learning system with less labeled data, and how can we use different types of the labeled data or even unlabeled data. And well, I'm mostly focusing on how to use unlabeled data to improve the overall accuracy of the model and in testing, in a testing phase, right? And also, well, we've been working a little bit with the metrics of how to assess how good a data set is at first, because sometimes, and well, I think it's not sometimes, it's like 99% of the times, computer scientists train their model with a data set that they don't really know what's going on, right? Without that much information, if it's really representative on the problem that they're trying to tackle, and things like that is pretty much information that we're missing. Okay, so we're being well. That's, you could say, some of my academic concerns so far, and well, I wanted to discuss it a little bit. And well, I'm organizing. Well, in case if you're interested, this is of course for academic purposes. Track on medical imaging using deep learning and computational intelligence in the World Congress on Computational Intelligence that's going to happen in Glasgow. So if you have a paper, you have like a week to send it, because the deadline is like in 1 week. But well, sometimes it happens, right? And well, that would be pretty much it. So if you have questions, or thank you.
I have a quick question. This is not technical. This is sort of a more general question. I found the statistics of the life expectancy in Costa Rica is amazing. So why has Costa Rica had such a success with the implementation of AI in the healthcare system and other countries lag behind? Do you have any idea? Could you give some speculation?
What do you mean exactly? Like,
I mean, it seems that you've had a lot of success using AI to bolster the health system in Costa Rica already. So why are the rest of us not there yet?
Well, still we are starting, right? I mean, these platforms, some of the physicians, well, it's like, you could say, local links that we have. It's not something systematic. That we still are, you could say, having conversations with our national health system administrators on how to implement it in a large scale. The good thing is that we have right now, we had like 1 year or something like that of having the EDOS system, that is a national informatics system for gathering data, and it gathers medical imaging data, all different types of data that we have, but still is something that it's just been in process, right? we still have to develop really lots of experience on how to implement it really in a systematic way. So still we have lots of road ahead, right? Thank you.
Any direct questions? Otherwise, we can move on to the panel discussion. Okay. I would like to ask the other speakers from this session to please join us on the stage. So to kick this off, I have a few general questions, and I'd love to get your feedback. So the first question is, the key to all of your use cases is access to quality data. Where in the procurement and implementation of data do you have the biggest challenges? Is there like a bottleneck, and how does that differ among your topics?
So I think the main issue that we found is, so we have a lot of medical centers that come and say, hey, I would like to use your system. I have tons of data that you can use. But then when you ask, okay, do you have a informed consent that says that data might be used anonymized for other purposes other than healthcare? No. And then that's something that goes to waste. So you end up collaborating with really large centers who already have a lot of research and development, so they already have a general informed consent that specifies that. So for us, in terms of medical image, that's the largest bottleneck. So there's no, I mean, you could accept that, but then it won't be legal and you might run into issues. So that's the main issue. The second issue then is with that data. So if we are saying that the doctor's sensitivity for an X-ray is 60-something%, then you have to double check that and then make sure whatever they are giving you is not a good gold standard. You have to have it reviewed at least by 3 doctors or 7 doctors or whatever, something that we haven't come up yet with a clear answer, but and that takes a lot of time. So that for us is the main challenge. So we figure out that the good centers you can collaborate with, they have the regulatory matters already in place, and then you have to take a lot of time to put that. Otherwise, it's garbage in, garbage out. So those are, in terms of medical image and AI, for us, that's all the 2 main issues.
For us, in our case, we cannot. There is no like public repository for these kind of images because it's a proprietary technology. So we need to generate our own images. And the most important challenges is when we are working with these organizations who can generate those cases. Sometimes they are not considering that some diseases are multifactorial. So for example, when we were developing the tuberculosis test, many of the times doctors did not know if the patient had HIV or diabetes or whatever situation that can change the immune reaction. It was important for us because we need like to have this previous information to know what we were feeding to the algorithms. So it's very important for us that when we are training algorithms, we need to be working with organizations that can actually give us the complete overview of the state of the patient at that point. So it's not easy. It costs a lot of money to do that and a lot of time, but it's the only way that we have found to actually feed correct information.
Well, I think there are lots of human factors and organizational factors that have been already mentioned. But I think that also from the technical perspective, there's a lack of metrics to say, for instance, how representative is a data set, if it's good enough, is it heterogeneous or homogeneous enough, and also a systematic way or pipeline of how to statistically compare the performance of different architectures and really measure if it's really accurate enough. And of course, as we are talking about health, is something I think very sensitive, and well, it's something that hasn't been really, I think, thoroughfully addressed in, at least from the academic perspective. So
we use NLP, and it's a challenge because there is no enough research in Spanish. I mean, applied to Spanish field, and I think that is one of the challenge. And also the data that are for our specific population that are not representative of all the cases. As I said before, we have millennials, and millennials are not the same as centennials, older or younger people. So we are now making an effort to integrate other ages in our database because we have a particular population.
And I think something you mentioned, so, but I think it's very important. There's been some news over the media about this AI, racist AI or biased AI, and I think that's something very important that we need to take into account in order to provide good services. And it might be a bottleneck. So if you don't account for gender, if you don't account for race, you might end up being racist or discriminatory agent. So I think that is not yet a bottleneck, but it should be, and it should be taken into account.
Another thing that he mentioned is that it's important to integrate the social and cultural differences, because I mean, just for natural language processing, is different the context in Colombia and in regions within Colombia. So it is also a challenge.
So sort of following the AI pipeline, you know, once the data goes in, you want something to come out of the model. So how do you handle uncertainty of AI in your activities? Alice had made a comment asking about that during, I think, one of the presentations, but just to sort of see if that's something that you guys are working on, what sort of methods you're using.
Also for images, I think the easiest way or the nicest way is to show what it's called activation maps. So that's something, it's a way of representing where the AI is looking at to say there's a consolidation in that chest, and I'm saying that because there's something in this area that caught my attention. And then a doctor can, it's similar as a doctor, the process of doctor scanning the image and saying there's something here. So in that type of image, I think it's quite straight, so you can make the AI quite accountable. For other processes where you have to measure volumes, where it's not as easy to interpret the human, I think that's a real challenge. Because the validation is done against some other gold standard who also needs to be eventually validated by human. But for images, for like simple images where you are saying that that's something abnormal, I think most of the companies doing these services, like such as Centelite, we all like figure out that it's an activation map is the nicest way. And for other areas, I think there's still a challenge ahead.
For us, in our case, one of the most important things that we need to do is to eliminate that uncertainty, because this is a diagnostic test which needs to give result, positive or negative, for example, in the case of an infectious disease. So our most important goal is to eliminate that uncertainty by comparing always with the most recent and most accepted golden standard. So again, in the case of tuberculosis, for example, not all of the countries are using GeneXpert. So in some cases they're using culture, in some cases are using real-time PCR. So what we decided is to use whatever the WHO was using as the real golden standard. So every single test that we feel is always compared with gene experts. So it makes the process complex because not every single country has gene expert. It's very expensive because in some cases, this gene expert needs to be paid by us. But it's the only way. And in the cases for example, the algorithms had some level of uncertainty after going through the algorithm, the neural network. So what we do is we do not present any result. So we force the user to do another test. And normally that corrects because sometimes it's about the execution and sometimes about the photograph, but this is the way that we do it.
Just to touch on something you mentioned, that you always use the most recent golden standard. So if there is some sort of a development made and the gold standard is improved, would you then update the model regularly?
Yes.
Or yeah.
Yes.
Okay.
Well, as I mentioned earlier, I think that using stats is very important because I found in our area in our field in computer science that most of the papers, when they have a new architecture that they say that is better than the rest, they compare just the results of a specific sample. They don't do a really systematic statistical analysis, like normality tests and things like that. And it's something that is in academia. You can find it very easily in academia. I have stats colleagues who often tell me that, it's not really, something meaningful that some of the researchers are reporting. So it's something that you can say that is easily transferable to industry if we are teaching our students not to do it like that, right? And in the specific case of computer science and in Latin America, we found that our curricula has to be strengthened with having like all this stats background, math background, because it's really, really important to design a fairly, let's say, a good pipeline for statistical validation of the results, because otherwise we will be very uncertain what's happening, right? So it's something very important, and it's something that we have to discuss first in academia and also in the organization of our curricula and our stuff, because statistics is something very useful in data science, and data science is transforming how things are being done. And other, you could say, disciplines should also be in the lookout of these changes, right? Because there's been this discussion of the emergence of new disciplines like computational pathology, computational radiology. Or for instance, in radiology, they have this thing named radiomics, right? Where they have these features that are extracted by a computer. And now we have deep learning, but that's learning pretty much the features from the data. Thing is, the data is really good for learning those features. So how do we know? We have to use stats for that. So I really insist on this point.
Well, we have handled uncertainty, I think that in two ways. Mainly from the part of the data science team, including sometimes more variables to make a better picture. Because as I said before, it's important to know age, gender, socioeconomic factors, risk factors for disease that include climate and a lot of things. So including more variables is important, but can be tricky also. And in the medical part, which is my part, we curate the knowledge base with doctors, and we do cross validation. I mean, the machine or the algorithm says diabetes. I mean, and the doctor review and say yes or not. But as I said before, the challenge for us now is to be wider, to be representative, because we are focused mainly in millennials, and it's important to go to their
Sort of to add on to what you were saying about validating it from feedback from doctors. I was wondering, with your NTLI, do the doctors who use the output also give feedback sometimes? Do they also say, I don't agree with this, or yeah, that looks exactly what I would have guessed, so I'm going to give you positive feedback?
So we do get feedback most of the time. So for example, we have some funny stories on doctors saying like, I do not agree with this measurement, and then we have two other doctors review and say, it's measured well, that's the size of the brain, and the doctor saying, I don't think that's atrophy, and then the system saying there's atrophy, and then at the end you say, okay, yeah, You don't have to say that there's something wrong, but the system measured the brain correctly, and for that particular patient, it says that it's something abnormal. And so those situations, I think we're gonna run into those situations quite frequently. At some point, obviously the system is not 100% accurate, so there's discrepancies in diagnosis. So we do receive that, and then we try another different doctor to review that and help the doctor. But it generally is this discussion, this goes and forth and saying that you might not agree, but at the end it's just a diagnostic support. So what we tell and encourage doctors is that they only use it as a support, and then if they have not agreed, they let us know and then review. Like so far, those mistakes most of the time, I would say 70% of the time, were the system was right and the doctor did not consider something, and the other part, the system was incorrect, which might happen. But most of the time, I think they like that of having someone to teach. It's pretty much of having like a resident, right? So you have a fellow resident who's like telling you what's up, who's asking sometimes annoying questions, and so we are used to that model of having someone saying, look, there's something here, and you can say, yes, you're right, and then, or you can say, no, it's not consolidation, it's something to do with the way the X-ray was taken.
So I'd like to open up the floor if anyone in the audience has any specific or general questions for any of the speakers. Is there a microphone available? Thank you.
Hi, my question is for Mauricio. The idea to define a workflow that will not change the way the medical are currently offering care is very interesting. And one point that caught my attention in your presentation is that you defined that the images are uploaded to the cloud platform so you can run the algorithm over these images. How this integration was performed, for example, it's all available for modern equipment. It's possible to integrate such kind of solution to all the MRI devices. How do you define the strategy to upload information to the cloud, considering different equipments in the industry?
So that's a good question. So we run with very different departments and systems. So most of the hospitals, they have either a company giving the service of a risk and a PACS, which is the system that organizes the medical images in a server. So there's a Philips, there's ACFA, there's many other companies who actually control that. And then, so that's something we work with them in order so they can give us access. And then the second issue, we would say that not all the companies want their patient information in the cloud. So some of them, as a client in Chile, they ask us to actually put a physical server in their hospital, and then from there anonymize the images and then send it. So I would say, in terms of the connection process, that's the more tedious part, because we have to accommodate for whatever client asks. So we haven't had like 2 or 3 clients who actually were exactly the same in terms of specifications, but most of them we have to work closely with them and then adapt our system to connect. At the end, so the last part, which is the AI part in the cloud, is the same, but then if it goes through a VPN or if it goes through another different connection, we figure out and we work that with the client. So we haven't found yet a way of standardize that, because there's a lot of there's not a clear market dominant in terms of servers. There's a lot of small companies that provide that. So we have to work really hard to adjust us to the client.
Hello, hi, Helmi Zakaria. And I have a question for Mr. Mauricio Faris. That was a pretty impressive solution that you provided. My question is that imaging sometimes is used for obviously diagnostic, but coming from my physician background, I know it also sometimes being used for what we call a radio conference, or sometimes people call it patient mortality review, right? And there's a lot of cases in Malaysia, for example, like after some incident happen, then those imaging will be brought up back, and some poor intern will be scolded of like, how could you miss this, right? So I wonder whether your solution have also been used for that, and whether those human doctors that missed the sign in the first place and have been compared by the finding of your platform, and how does the medical community take it from that perspective? Yeah. I mean, if that ever happened.
It haven't. It didn't happen yet. At some point, there might be some case like that. So so far our regulatory approval is as a diagnostic support system. So at the end, the doctor is responsible of signing a report saying that you have breast cancer or like something in your image. So if that ended up in the malpractice lawsuit, that eventually the doctor is responsible because he's the one who signed the report. A different scenario, which I think it's the one we want to have in a few years, is that the system works as a standalone system. The FDA approved for retinopathy. It's a screening system that it doesn't need a doctor. So if that system makes a mistake, it's entirely the responsibility of the system and its company. I'm not sure how they're handling the shielding strategy for lawsuit. But so for now, the current practice and regulatory approval, it's pretty much the same. It's as if you saw an image and then you make a decision on that. It's still the doctor responsibility. In the future, I think that's going to change. So far, we haven't run into that cases because no one likes that as a doctor to be involved in that. So I hope we don't get one of those malpractices. But I think in the future, the real challenge will be how are we gonna make those companies accountable for any potential malpractices that arise as a result of their use.
I have questions to Lina Porters about, do you think that it's available to have a sexual debate and not only focalize on the kind of medical system or hygienic system about pregnancy, for example, by ignorance of the people or by no access to the health center, that you can use this concept of sexuality because it's a real behavioral problem of the humans, and also about the technician, where you think it's for all, because we are in the epoch very difficult for science about the populism and a lot of dispute, financial market and the consumers, and you have to put the man in the question. That means to have direct access to show, to demonstrate what you are doing, that it's very, very important, not only be a kind of mechanical system that will be attacked about this kind of populism.
I hope that I have understand your question. If not, you can ask again. Talking about the sexual debate, I think that in our countries this is happening. So people are talking about sex, but I think that with the new gender differences and sexual orientation differences, we have a lot to do, but not only with people. Well, I mean, with citizens, but also with doctors. Because last year we have a meeting about gender and sexual orientation with doctors, and for us it's still difficult to talk about gender differences, gender orientation. So it's something that have, as a society, we have to evolve in that. In my country and in Mexico, the governments are trying to improve the access to contraceptives. I am not sure if this is occurring the right way. I mean, in my country, there are young girls from 14 years with implants. So I think that there should be a balance between how we decide to start sexual life and Yes, we have to think about really not just put contraceptives to everyone. It's difficult. And that for the first question. I don't know if I answered. Yeah. And for the second, it wasn't clear for me. Can you repeat, please?
And we said it's about this question that it's linked to sexual debate, that it's interesting to observe that we have a gender debate, discussions about a lot of things of sexuality, but we have still a problem at the level of undesired pregnancy. Then it's a question, and not only to reduce, to treat the undesirable pregnancy, because this is a symptom of the problem that you have to debate. And about this, the second question is, it's very important to do the development of the techniques of the machine, but of the systems. But in any way, we are into a very difficult time, historical time of populism, of science attack, and what is man? What is the man, the human, in all these questions? And that it's important to think about this, also to explain to the population that it's important how this development science, you have the techniques.
Yes, we have found in our platform that for some people with what I said simple issues, they prefer to talk to a doctor, even if with the platform can solve the question of the issue, because yeah, there is a part of humanity that we need to take into account. It is important. It's not just about say you are not at risk, yes, or there is risk, no, yes or not. It's not always a yes or not question. There is a humanity behind, and that's also the reason why we are not we are not just focused on AI and give yes or no answers, but also we are focused in improve doctors' time, because maybe you know, doctors, we don't have a lot of time. We are always busy. Someone said before that to have doctors traveling is really, really difficult. So I think that doctors also deserve to have more time for them and for their family. And final thing is that in our platform, we are making an effort to educate doctors in sexual rights, and also to speak with the patients about that. Because I agree with you, unintended pregnancy is a symptom of there is something wrong, bad words.
So I think we have time for one last question. Darlington?
Okay, so one of the things we've been working on is an assessment platform, and I noticed that you guys were quite protective of the details of your system. So I wanted to ask this, what do you think about the response if, say, PAHO had a system, an assessment platform, and was standard for the region, so that your AI solutions, you test them on the platform in two scenarios. Either you just take samples, test samples, and then you give back the result from your system, and then it's analyzed to sort of gauge your performance of your AI system. And then the other will be submitting your AI system. What do you think your personal, what will be the response from your own company to such a platform? Are you open to it? And then more broadly, just what do you think about the region? Do you think this would be a good idea? Would the region be open to such a platform?
So I think so such things, and there's these competencies, the MICAI, or there's a lot of competencies where you can do exactly that. So you can, they give you a test set, and then you put your model, and then they calculate the metrics, and they give you the results. And I think that's great. There should be a way where we can test for the same data set the performance of the system. I do not think that that necessarily means that the system works better in any setting. Usually those data sets are 20 images or something. And then it gives you a good idea if your model is like competitive. So if it's the highest score is 0.94 and you're 0.92, you can say you are around the state of the art. But then it doesn't tell you where your model it has a good external validity to a different data set in somewhere in the world. So if you're gonna do it right, in my opinion, you will have to do it like a very extensive test data set that includes gender issues, race issues, demographic issues. So you could say we tested with this very integral data set, and for all these populations and all those settings, it has a approval value of 0.9 something. So I think that will be great, and I think that's definitely the first step. But that doesn't mean that you have to show how you get there, your model. So you can run your analysis and then submit the results without having to show your R&D results or work for many years. So I think it's independent. You can do it as a systematic testing without having to reveal how you're doing your. And I don't think not knowing that, it shouldn't impact the precision of the system. So it doesn't matter if you use a BGG with how many blocks, whatever. I think if at the end you pass the test in a standardized test that includes all that, I'm happy for you. I mean, it's perfect. It doesn't matter how you get there.
But my question is, would your company be interested in doing such a thing if it was a standard in the region?
Sure, yeah, definitely.
And it's also directed to everyone.
In our case, for example, is these are rapid tests. There is already something similar. There's an organization called Fine in Geneva, which is trying to standardize how new tests are getting into the market, and this is like the first step to getting into the pre-qualification of the WHO. So, for example, our test for TB was challenged by Find, and it's not about images and doing this online, but they send you, for example, a block of 300 samples from patients with from different parts of the world with different kinds of conditions that can affect TB. And you run the test. This is a blinded test. So we run the test and we send the results, and Find will give you, so under these circumstances, with this problem, the block of samples, you get this accuracy of it. So it's very important. So if it can be done in different regions, that will be very important, because for us, actually, having this kind of information is crucial to really get what is the accuracy of the test in different conditions. So that will be very important, I think, for every single company, because that is the way that you can demonstrate that your platform is actually accurate and not depending on how you run and design your internal clinical trials or external clinical trials or pilots.
Well, as for me, in my case, I'm open to share the models and everything, since I'm working in academia, right? But I think that even though there's of course, there is a strong lack of open data sets that come from underdeveloped regions, I think that as, for instance, in Latin American region, we should try to build up efforts from academia and also hopefully from industry to build up these data sets so we can have like a real good benchmark. Because I remember once I was in Canada and we had this also a panel like this, and there was someone in the audience who pointed out that some of the data sets that one of the guys in the panel, there's a company named 16-bit AI, I think, and they are from Canada, and they were training a chest ray image analysis tool. And then she addressed how there was a newspaper article in Toronto, a newspaper, and how the dataset was not well, it had some flaws on the labeling, and how they were using a mislabeled dataset, right? So I think it should be a very, you could say, like a more systematic effort from the society, not only relying on a specific company or a specific university or a set of universities. It should be something more systematic, because data is, well, where we're relying on to build up these models, right? And it should be very significant, as I said, statistically well designed from that point of view. And well, I'm open for join these efforts if anyone else is up to it, right? Because I think it should be even region-wide or hopefully worldwide, right? Because it's you could say data is generated by society, and I think that, well, I'm from the point of view that of the open data point of view, right? That it should be owned by society. Well, and then the private companies could have their own private model that is running to these benchmarks that are publicly available, and we all would be very, you could say, secure that we are using a model that has been properly trained, right, and has passed some series of benchmarks. And I think that we have to have this effort, like in conjunction, right?
We are committed to cooperate to find a standard. We are now part of the symptom assessment group, this initiative, but we think that companies are not the only way to do it. We have to cooperate with research institutions and with hospitals because they have the key data. At least, well, they have images, they have clinical records. So we have to cooperate, everyone, with all of them to find the right standard to validate things. And I think also that maybe WHO would lead some initiative to have public data that we can all use to train and also to validate models, because that's the main problem. We don't have enough data, enough images, enough clinical records to analyze. So I think that it will be it must have to be an effort of everyone, because we are talking about health, we are talking about life, and we are talking about technology that can improve people's lives. So I think it's an effort of everyone.
All right, well, please join me in thanking the panelists again for their presentations and for the lively discussion.
Now we're going to have our lunch break. The lunch will be available in the same place as the coffee break. So